All right, continuing on with angle relationships here in our lesson 3 about angle-angle similarity. A little warm up here, list the corresponding angles. Suppose the triangle BHX is similar to triangle KRC. Corresponding angles, if we were to list those out, get my pen working here. Corresponding angles, we could say that angle B corresponds. I'm trying to get my pen to actually cooperate. There we go. Angle B and angle K. And then we could say angle H and angle R. And then angle X and angle C. Based on how the triangles are labeled, those have to be our corresponding angles. And then write the ratios to identify the proportional side lengths. So we could say that BH to KR has to be equal to HX to RC, which has to be equal to BX to KC. If we're going to have the same ratio for them to be similar figures, those three ratios have to be equal to each other. Okay, so key term we're looking at today, angle similarity theorem. So moving on to a little getting started activity here. Graphic artists use knowledge about similarity to create realistic perspective drawings. Choose where the horizon should be and a vanishing point, a point where all the parallel lines in the drawing should appear to meet. And you too can create a perspective drawing. So if you've taken art yet, or possibly in art, vanishing point is something you'll talk about in art. Point in the distance, if you imagine like sidewalk or railroad tracks going away to that vanishing point, it creates where two parallel lines look like they're going to one point in the center. But by doing that, we're creating angles that are equal to each other. So in this case, as it says in number 1, suppose the vanishing point A and that side DE is parallel to side BC. How can you demonstrate that triangle ABC and A is similar to AD? Well, because these corresponding angles have to be congruent to each other. And then obviously they share, and we'll change that to color green, they share this angle as their third angle. So it creates two similar triangles where the angles are all congruent to each other, which means we have similar figures. So drawing a horizontal line in the path to create another similar triangle, and then it says sketch a tree at the line using the appropriate scale factor. So in other words, drawing another line, we could create, if I can draw a straight line here, we could create another set of similar triangles. If we're looking at, say, they call this triangle 1 and triangle 2. All right, so moving on to activity 3.1. Now, it says use a protractor here. I'm going to just write some angles out so we can share it digitally. Can't really show you a protractor here on the screen. It says you have determined that when two triangles are similar, the corresponding angles are congruent and the corresponding sides are proportional. To show that two triangles are similar, you need to show that all the corresponding sides are proportional and all the corresponding sides are congruent. So we're going to explore an efficient method to determine if two triangles are similar. So if the measure of two angles of a triangle are known, is it enough information to draw a similar triangle? So we're going to look at this possibility. So I'm going to draw two triangles, and I'm going to do my best ability to make them look similar here. Draw that black one. I'm going to draw this blue one. And if I were to tell you these are similar triangles, and I know for sure that call this angle A, B, C. And I'm going to say A, B, C. And if I know that angle A is congruent to the new image angle A, and I know that angle B is congruent to the new image angle B, based on knowing angles of a triangle, adding up the angles of the triangle add to be 180, angle C has to be congruent to angle new C. Put a third mark on this one. So for instance, if I know that, make up some numbers here, measure of angle A, let's say that is 30 degrees. And let's say I tell you the measure angle B is, let's say 70 degrees, although it doesn't quite look like 70. We can know that using the triangle sum theorem to measure the angle C. We know that they have to add to equal 180. So 30 plus 70 gives us 100. So we know angle C has to be 80 degrees. And if angle C in the original triangle is equal to angle C in the new triangle angle C also has to be 80 degrees. All right, so draw a second triangle. That's what I did above. They said label it DEF. I labeled it as our new triangle ABC and used the original as our pre-image. And we measured those angles. That's what I was showing you, comparing if I know that two of them match, the third one has to match as well. So E, based on your knowledge, what other information is needed to determine if two triangles are similar? It's the measure of the third pair of corresponding angles is needed. And we need to know if the corresponding sides are proportional. Because similar figures will have that proportional ratio between their sides. So F, determine the measurements to get the additional information needed and decide if the two triangles are similar. And based on what I drew, if my drawings were better, we'd say yes, the third pair of corresponding angles are congruent. Just emphasizing that the similar triangles maintain congruency among the angles, not the sides, but the angles. And the corresponding sides are proportional. Okay, as it says, we've just shown that given the measures of two pairs of congruent corresponding angles of a triangle, it is possible to determine that two triangles are similar. In the study of geometry, this is expressed as a theorem, and this is known here as the angle-angle similarity theorem. It states that if two angles of one triangle are congruent, the corresponding angles of another triangle, to the corresponding angles of another triangle, then the triangles have to be similar. So moving on, now that we have that, to activity 3.2, using the angle-angle similarity theorem. It says identify the triangles that are similar by the angle-angle similarity theorem. So with number one, we know that angle JHG and JDC are corresponding angles to each other. So they have to be congruent based on what we talked about, knowing that vanishing point idea before, because these two lines are parallel to each other. So it makes those two angles have to be congruent. And they share angle J. So now we have proven that two of the corresponding angles are congruent. So therefore, triangle JHG is similar to triangle JDC. Okay, for two, let me zoom in, make it a little bigger. For two, we can say for sure that they share that 90-degree angle, so we know those match. And these two pair angles are vertical angles. So they have to be congruent based off what we've learned in previous lesson about vertical angles. So again, those are similar triangles. So we can say triangle VYZ is similar to triangle VWX. Okay, for number 3, they're showing us that one pair of angles are both 29 degrees. So we can say this angle matches that angle. And we know, again, they share that angle in the point of the triangle there, angle RTM. We know they share that one. So it is congruent for those two. So based off that, again, we know 2 of the angles. So we can say that triangle TMR is similar to triangle TNS. And for number 4, so we got 2 triangles. These are kind of turned at a different angle, but we know they share that right angle. We have an angle here that is equal to each other, the small angle PSQ, and then this angle PQR. And then from there, we can look at the other angles, and judging by those angles, PQR and PSQ were the 2 I just mentioned. Angle P is the same in both the triangles. So they both share this angle. So again, we now have determined we got 2 angles that are congruent. So these triangles have to be similar to each other. So triangle PQR is similar to triangle QSR. All right, activity 3.3 on our next page says use what we've learned about triangle similarity to answer each question. All right, so we got a bunch of lines drawn here, which shows that BD is parallel to HG. They're also telling us that AH is parallel to DF, and AH is perpendicular to AG, as well as DF is perpendicular to AG. All right, so they want to know first, for number 1, is triangle ABC, I'm going to draw it, trace it here, triangle ABC congruent to triangle AHG. So AHG. And we can definitely say yes, they share angle A at the top, and then we got these corresponding angles based on the idea of the vanishing point earlier. They share those angles, so yes. They use that triangle angle similarity theorem, so we can say triangle ABC is similar to triangle AHG. Okay, if we go to the next one, I'm going to erase that so I can resketch on that. Want to know about triangle ABC? Is it similar to triangle EDC? So again, I'm going to go trace those. ABC, similar to triangle EDC. All right, so looking at triangle ABC and CDE, we know for sure, again, we got vertical angles here that have to be congruent to each other. We also know, based off that, angle CAB is congruent to angle CED, and angle CBA is congruent to angle CDE. So if we look at CDE, just to show you what I'm drawing out here, or what I just mentioned, CDE is congruent to angle CBA. Draw 2 lines on that. So again, we have 2 angles that are congruent to each other. So yes, we can say that triangle ABC is similar to triangle EDC. So for the next 3, I'd suggest pause the video, see if you can match up and use the triangle angle similarity theorem to see if you can identify the angles that are congruent and match up the triangles, then unpause it and see if you were correct. And now that you've done that, hopefully you will discover all 3, 4, and 5 can all be said they are similar. So I'm going to just write here across all of them, all are similar. It applies to the next two as well. All right, and wrapping up here at the end, talk the talk, bow tie triangles. Says you can draw special triangles known as bow tie triangles. First, draw a pair of parallel segments, as long as we know those lines are parallel. Then connect the pairs of endpoints with the line segments so that the line segments intersect like this. Are bow tie triangles always similar? And the answer is yes, they are, because they always have a pair of vertical angles, and because these are parallel to each other, we're creating alternate interior angles that are congruent to each other, and that alone gives us two angles that are congruent. So yes, they are always similar. All right, and that wraps up this third lesson about angle similarity.